Okay, good afternoon, everybody. Thank you for being here. I know I'm either between lunch and the morning session, or maybe lunch is being served and you just didn't know. Either way, thank you for being here. My name is Sudheer Matta. I'm with Juniper Networks. We'll talk about sort of AI and what we're doing with AI in networking and sort of the impact that we're driving from that. So I have three fundamental topics here. So we'll talk a little bit about what is AI in networking today as it stands, and then what are we doing with AI in networking in higher ed, specifically in education, but higher ed for sure, and then a little bit of what the future of AI in networking looks like. I'm going to speak to this from a more campus and branch perspective, from a wired, wireless, SD-WAN, NAC perspective, but obviously everything's fair game. So thank you for being here. So I'm going to start with just the outcomes you should expect from AI. This is what we've been driving in a lot of our customers. And so for me, AI is obviously very buzzwordy, and a lot of everybody has to say AI these days. Otherwise, you don't get a speaking slot. So for me, AI is really just actionable insight. It truly is what outcomes can you drive. So 100% of the networks that we've gone to deploy with Juniper Networks, with our AI-driven networking, we've driven three outcomes. So I'm going to keep coming back to what are the three things that you should expect from us as we go through this thing, or any vendor to that matter. So first, it has to be about student experience. It has to be, at least especially if you're in higher ed or K-12, it has to be about student experience. 100% of the places that we've deployed, we've delivered fewer tickets from students, fewer complaints from students. Then, if once we've served the primary community that we're after, then it has to be about the IT experience, about ability to scale, ability to operate, ability to become efficient, all that kind of good stuff, save money, all that kind of stuff, right? And then finally, it is about being cost effective, truly, because higher ed is always under price pressure, has to be the best value for money. So these are the outcomes we drive, and we're aspiring to drive. So I'm going to step back and actually walk you through a little bit of how should you think about AI in networking. I'm talking about campus and branch, and sort of what we've brought to this. My favorite, level set slide on this comes from Andrew Negg, obviously a Stanford professor. And his simplification of AI, for me, sets the table for how we've actually thought about introducing AI into networking, right? So, Andrew says, basically there are four types of AI models that are in deployment today in the world, right? Four of them. So most of the AI things that we see in the world are in the supervised learning, basically labeling things and then leveraging labeled data to basically do either predictions or proactive assertions. So that's why that bubble is the biggest. So it's big, and we'll obviously connect this all to networking, what we're doing, how we're doing it, all that kind of good stuff. But a lot of it is supervised learning. Then unsupervised learning. Unsupervised learning, very powerful in that you don't know what is the existing labeled data. I'll give you an example of that, right? Let's say you take an iPhone and you connect it to your access point at home, or you connect it to an access point at a university or at a Home Depot or at the Niners Stadium, right? How the phone behaves is very different. And what a certain signal strength for the phone means is very different. Can we actually, based on what we are learning as we go, can we learn from unsupervised learning? Tremendous possibilities, and we brought unsupervised learning to networking as well. Then The biggest one is reinforcement learning. Reinforcement learning is, look, we've made a change in the infrastructure. The impact on the student experience was this, and then okay, that was good or that was bad, and then reinforce that. So reinforcement learning, and obviously the transformation in our generation, right? The next industrial revolution is generative AI. And if any of you watched the keynote from Jensen at NVIDIA last week, you know, I was just walking my dog over the weekend. I was listening to it. It hit me. I mean, what Jensen says is, look, all of the internet till this day today is you go seek something and it's already pre-programmed. It's a website, it's a video, it's a podcast, and then you retrieve it, right? That's been the internet so far. But the future of our world here is everything is going to be dynamically generated for you. That's what ChatGPT is, and a lot of the applications that are out there. Generative AI is going to have the most profound impact. Obviously, you all know this, and we all have been bombarded with this. I want to speak to what can it do in networking, right? That's what this is about. So, so without further ado, the one that we found has had the biggest impact in networking for us as we built product. Maybe just a little bit of introduction for myself. I came into Juniper as the head of products for a company called Mist.com. For the first 5 years, we were explaining to people that we were not making sprinklers, that we're actually in networking, but Mist.com. So anyway, but we came in 5 years as an independent startup, got acquired into Juniper. Now 5 years. This April 1st will be our 5th year anniversary in Juniper, 10 years. And we've completely changed networking in the sense that literally the world's largest networks run on Juniper Mist, right? Fortune 1, Fortune 2, Fortune 4, Fortune 11, Fortune 17, all retailers, financial services, education, all this kind of stuff. I'll give you examples. So that's my background a little bit. So I lead products for this team. But reinforcement learning. So again, the model is very simple. The AI, is basically when we started to think about reinforcement learning and wanted to build this thing, the question we were asking was, can we eliminate a human trying to optimize a network, right? Can we eliminate the CCIEs and JNCIEs being able to sort of hand chisel higher ed networks? And today I can confidently tell you 100% of the universities that we've deployed in around the world, and I'll give you a few names, not one of those access points is optimized by a CCIE or a JNCIE. Today, I'm sure all of you know enough applications. I'm addicted to playing chess on my phone. A human cannot beat a machine in chess. That day has passed. I'm here to tell you a human cannot beat the Mist AI engine in creating the best RF network on a university or a K-12 or a office campus, right? That day has passed. So what have we done? Let me start with reinforcement learning, and I'll give you some examples. Actually, I have a customer example coming into this. So first things first is let the model just learn the network and self-optimize it and self-heal it and self-drive it. Right? All of that sounds very buzzwordy. Every time I say AI, they add an extra zero in my paycheck. No, that's not how it works. But this is real. This is what we've done. And when I show you the examples of the universities we've deployed at, it'll come to life for you. So very, very critical. Supervised learning for us, what it meant is just learn the patterns of networking. And I'm going to show you this product a little bit. If you've never seen the Mist product, basically, we are constantly learning patterns of network and basically say, hey, that looks like an anomaly. I got to go take action. Hey, that looks like something that's abnormal. I got to go, alert somebody. So that's what we use for supervised learning. So reinforcement learning is to self-optimize, self-drive, self-organize the network. Supervised learning is to alert and get ahead of IT learning this. These are some of the outcomes that we've driven. These are the public names I can show. Our largest current rolled out network is MIT. We've displaced Cisco at MIT during the height of the pandemic, about 10,000 access points. In a span of 4 months, the entire campus. Mark Sillis is the VP of IT at MIT, and he said, by the way, just a history lesson, Mark and I personally deployed access points at MIT when I was at Cisco many moons ago. And so we got an opportunity to displace the MIT network, all missed access points. And he said, it's like I woke up out of a dream after I've seen this. And so we've cut the student opened IT tickets or student opened Wi-Fi tickets. How does a student open a ticket on campus? They go to Reddit and say MIT Wi-Fi sucks. That's how they open a ticket. We've cut that down by 90% as measured by their internal systems, right? So reinforcement learning and supervised learning can have that kind of outcomes. Walmart, since their name is up there, that's Fortune 1. I have 330,000 access points deployed in production there. We have 60,000 switches deployed in production there, and they are the world's largest enterprise network, and walked away from their existing vendor, completely using AI to do a lot of this. Unsupervised learning is actually what we use to deliver rich mobile experiences on campus. What does this mean? When we built this access point at Mist, we built in a Bluetooth low energy antenna array into every single one of them. Right? I'm sure you've seen a Cisco, Aruba, Meraki, Aerohive access point. They all look the same. They all pretty much come from, with the same chipsets and everything. But we designed a patented BLE antenna array that sort of looks at like the one in the bottom there. And what that has delivered is at University of Texas Arlington, you walk into campus, the campus is a digital experience. You literally can find yourself, from your dorm room or from your home to the exact classroom with 5 feet accuracy. You could literally navigate yourself from your home in, wherever you live to the exact classroom, all the way navigating from Google Maps to in-building maps to everything. And how do we use unsupervised machine learning? In the old world, if you're a Cisco customer and a Aruba customer, they used to say, hey, you got to go map out this building. You got to, have somebody walk and say, I'm here, and map the whole building with location services. We've eliminated all of that. Literally, with unsupervised machine learning, we actually have been able to create basically the enterprise, the education institution as a digital enterprise, and be able to deliver applications, right? And so, again, if you come to the Juniper booth, which is right outside this room, we can give you a demo of location-based services. Last but not least, generative AI. Mist was founded in 2014, and clicking the wrong button. Mist was founded in 2014, and one of the visions for us was, hey, if Watson can play Jeopardy, I came from India. I never, I appreciated the complexity of the game Jeopardy. And, first time when my founder, Bob Friday, was saying, hey, if Watson can play Jeopardy, that's amazing. We could actually build a self-driving network. And so I started watching Jeopardy, and I was like, oh my God, it's actually not easy. You can't Google search these Jeopardy answers. And so if Watson can play Jeopardy, can we build a self-driving network? That was the dream. That was the vision of Mist. When we were all at Cisco, we were happy and, selling a lot of, gear to all of you guys. And, we acquired Meraki. Everything seemed good. Suddenly Bob Friday, our CTO of Cisco, left and started this company. And I was like, why? Who needs a new network? There's enough vendors already, right? And then that was the dream. That was the vision. If Watson can play Jeopardy, can we build a self-driving network? And so that was 2014, well before ChatGPT was cool and all these things were out there. And so we have been building sort of digital twins and models to actually build a network that sort of can run itself. And so with the advent of generative AI, what we have done is we've actually started to use external public, OpenAI kind of large language model systems to answer questions. How do you configure a Juniper Campus Fabric? Well, OpenAI, we've connected our systems to OpenAI, and it can give you the answer. But where this is headed is honestly is what can a large language model do in networking, right? Can large language models make meaning of the digital data and start to actually become more predictive and proactive? The answer is absolutely 100% hell yes. And you just need to have the right architecture for it, and that's what we're sort of working on. So if I summarize all of this AI in networking, it falls in these four categories. Supervised learning, these are all the models that we use. Unsupervised learning, this is the model we use. Reinforcement learning and generative AI. This is great. This is all theory. Now let's connect it to the practice of AI in higher ed networks, right? And so I'm going to connect it back to, I only want us to talk about outcomes. AI is a means to an end, and the outcomes I want us to talk about are we delivering amazing student experience? What is amazing student experience? Amazing student experience is students being able to carry education, carry their what they need to do on a campus anywhere seamlessly with zero complaints, with literally have just a ubiquitous experience of the network. That's what we are after. I'm going to give you, a bunch of other university names that are public that we've deployed around this. Second, obviously, how do we let IT become more efficient in operations, right? And third, finally, is how does this all come together? So let's start with amazing student experiences. So, when we deployed at UMass Amherst, and I'm going to play a podcast from Jim Molesky, the CTO, they saw a 90 to 99% reduction in support tickets. At George Washington University, deployed the entire campus in 3 months. UT Dallas, this is Brian Doherty. He will tell you, literally, their IT team is started to do more strategic things because AI is running their network. This is how it should be. At Winston-Salem, basically, it improved the quality of life for the IT engineer. That's probably the best outcome I've driven so far on this, right? We talked about MIT. Dartmouth College is our very first university. Literally, Mist and Juniper met on the campus of Dartmouth because they wanted a full stack wired wireless, offer, and we put together an offer on a sheet of paper, and then eventually the companies merged. At Dartmouth, no joke, they replaced 1,800 access points in their dorm rooms in 1 weekend, 48 hours, right? The entire thing. That's what COVID did to a lot of us, right? So you suddenly had to learn to do a lot of stuff very, very, very fast. And so at Dartmouth, basically it's network as code. I obviously, as you can tell, I work with a lot of higher ed. Dartmouth, I would say, is the campus that I hold at the highest esteem in terms of literally running the entire network as code. And they do a very good job. Brian Ward has done podcasts on this, right? And so internationally speaking, University of Oxford, University of Tokyo, University of Amsterdam, all kinds of international. So let's talk about just one university's experience. This is Jim Molesky. It's just a 90-second clip on their experience with Juniper. We were the wired network. Their wireless network was Aruba. And then, as they displaced this was sort of the outcome they drove.
Again, this is a year and a half ago. We found that the AI in Mist was more mature, is the way I would describe it.
Have you noticed a difference in the amount of time it takes to resolve a troubleshooting problem?
Absolutely. And I will also, so I have statistics that we've shown. Actually, I pulled so we use ServiceNow for our ticketing system.
Yeah.
And I looked at a trend for the last 8 years. And I picked a dorm. I actually picked 2 dorms, and I picked a administration building. On average, about 100 to 200 tickets per dorm on average per semester. That was on the old legacy Aruba. So again, we're currently, those same 2 dorms, one dorm had 1 ticket and the other one had, I think, 3 off the top of my head. So we went from 100 to 1 or 2.
99% drop.
Pretty much.
Yeah. What makes you think you could get, that's either 10 to 1 or 100 to 1 better
right
drop in tickets. How do you think Mist was able to do that?
It's the AI. So the way I like to describe it is I have a great engineer, knows more than most Aruba high-level engineers. but he works 40 hours a week. AI works 7 by 24, 365 days a year, never stops.
So, so that's sort of their experience. What I want to quickly show you the product a little bit, and it's again, this is another 90-second demo. So let me just walk you through how did we go about building this product. Obviously, I used to run Cisco product management for the Cisco wireless team before I joined Mist. We all came from basically a similar mindset architecture. We fundamentally flipped the script on when you go build a new network, it could be different. It could be based on user experience. So what we've done here is basically we were sitting in the NOCs of universities around the world, asking the question, hey, what are your top 10 issues in networking? And one particular engineer in South Africa, he said, Sudheer, I don't have 10 problems in Wi-Fi. People call in with only 2 problems in Wi-Fi. I was like, wow, what a grand oversimplification. What are your top 2 problems in Wi-Fi? He said, problem 1, people call in and say, I can't connect to the network. And then the only other problem they say is, hey, your Wi-Fi sucks. And that's all they know. They could care less what a MAC address is and everything. So we said, could we put physics behind the Wi-Fi experience? And that's how the whole journey started, right? If I'm failing, 75% of the time, and what's that 25%, succeeding 75% of the time, what's that 25% of failure, right? Is it DHCP? Is it radius? Is it ARP? Let's demystify that 75%, right? So obviously, every problem on the campus network starts with, hey, the Wi-Fi sucks, because our kids don't even know there's wires behind these damn things, right? So, so basically, if you could actually get down to every individual user's experience and say, pick a user and say, what was happening with that user's experience, right? And be able to actually understand the user's experience, collect, collate, and curate every single state transition for that user. And oh, by the way, when something catastrophic happens, having a packet capture waiting for you in the cloud. Imagine if you had the video footage of every crime committed in this world. This is the crime committed on the network, and we have a video footage for it every single time. On the MIT campus, we have about 60,000 students connect any given day. Not 60,000 students, 60,000 devices connect any single day, right? Of the 60,000 devices, they do 7 million state transitions in a single day. Of the 7 million state transitions that all these devices do, we have 700,000 packet captures waiting for the MIT engineer. If you ask them, how many do you use on a daily basis? None. That's the whole point of this, is collect this data and let the AI do all of the work, right? Literally, that's the whole point of this thing. So now you take this from, okay, so far so good. You have the right data, you have the cloud infrastructure for it. And this is why, if any of you have tried Cisco DNA Center, that's an example of how not to build systems for AI is building it on-prem, right? You got to build these things in the cloud and have this elastic scale, sort of basically, if you have to build the network that I just told you about Walmart, 300,000 access points, you need 16 Meraki logins, right? 16 individual unique logins because they can handle 25,000 devices per shard. We do 330,000 access points in one login, one instance. And then after the success of the wireless, they said, oh yeah, we want the wired as well. And so we have ended up deploying about 60,000 switches. That's what a cloud can do, what on-prem systems cannot do, right? And so anyway, so then you say, okay, great. IT experience, user experience is good. You're self-organizing, self-optimizing. Then the IT experience is, how do you actually make meaning of all of this data? Is you literally use this AI, basically. Supervised learning to get you proactive and let the systems watch the network and be able to alert you, right? So now I'm going to skip some of the NAC stuff, and because I just realized I'm over time. So let me just quickly speak to where are we headed, right? What does this look like? Everything I've told you is currently deployed in all these universities. Speaking of, if any of you are in K-12, we do Seattle Public Schools, Fairfax County Schools, the San Diego County County, I think the city, I think, is deployed, as Long Beach Unified, all kinds of school districts as well. Where we are headed with this is, if I summarize all of Jensen's NVIDIA talk, it's about digital twinning and having digital twins so that you can actually build networks, build AI models, build robotics, and do it all in the digital environment and then take it to the real world, right? So what we have done is we launched a product we call Marvis Minis. What it does is essentially it's digital twinning this user experience. Instead of digital twinning the network experience, we said, hey, we've always been about user experience. Can we actually have mini Marvises go out there and sort of digital twin the user experience and just constantly validate the network, constantly try to be what your student is trying to do. And that way, you don't even need to have students on campus. You don't need to have student in that classroom. You don't need the professor to go fail before you find. So truly 100% proactive, meaning identify issues before users ever suffer again. This is what we just launched in January, end of January. It's live production. University of Washington is an example of that, where we're displacing a very large Aruba network. And the idea is, if I have digital twins of users on my network, and oh, by the way, I want to do it with no extra hardware. It's no sensors, no additional access points. That's legacy. Use your infrastructure. Literally use your wired and wireless infrastructure as the foundation for digital twins, right? And basically, by the way, if you're going to go that far, completely learn the network. Do not do anything that requires manually. So in our digital twinning of experience, our digital twins, you don't have to say, I have 4 SSIDs at Stanford. This is the student SSID, this is the faculty SSID. No, we learn that. You don't have to say, these are the VLANs that we use for our professors and students and staff. We learn that, right? If the system is that smart enough, we may as well learn all of that. So we do. So this is, by the way, all in production in a lot of these large customers. So we basically launched a digital twinning experience, contextually learning, no extra hardware, always on and validating. And what does this do? It basically is constantly looking at the network and saying, is the network right now capable of delivering the experience that we are set out to deliver? And that's what this is. I know I'm out of time and I sped fast a little bit, but the idea is we could do this today on campus networks, and we've been on sort of universities around the world. So we are right outside this booth. If you truly are intrigued by this and said, hey, that sounds like the snake oil, let me try a little bit of that. We actually can give you a voucher that you could get a free access point and start your pilot right now, right? You do not have to get stuck with what you have because you haven't met Juniper yet. So the only people that have not bought Juniper wired wireless are people that have not seen a demo or have not gone to production. Everybody else has already bought it, right? So Stanford is sitting right here. So they're partnered with us, and lots of universities that I've name dropped as well. So with that, thank you very much. I know I'm well over time. I apologize, Jeff.
We have a minute or two. We're supposed to go at 12:35.
Oh,
so if anybody wants a question or you got one more slide, we're good for just.
Actually, maybe let me pause because I spoke all the words I had, so I should stop talking now. So anybody have a question? Does this make sense? Yes, sir.
Yeah.
Hello. Michal Krsek from Cessna, Czech Republic. This seems like you are building let's say, domains.
Mm-hmm.
What research networking has for now is eduroam.
Mm-hmm.
And the point is, those kingdoms are somehow interconnected.
Correct.
So, and one of the biggest issues we do have is the remote debugging. So I'm sitting here, not here, as eduroam is not here, but at UCSD, and not being able to connect to the network just because the eduroam stuff, there is something in it, and I'm not logging it into my home network.
Correct.
And the current state of the art debugging is I need to call from the UCSD to the Czech Republic and ask those guys if there is something. And this is real, bad situation. And I'm not sure how this work in that situation.
Super. Great question. We just did this at Dartmouth, and let me explain what we did. So for the last 20 years on a college campus, the way eduroam worked is you got to maintain your own NAC infrastructure, policy, all of this stuff on-prem. And then eduroam themselves, with all due respect, are running some legacy stuff themselves, right? And so we got legacy coupled up with legacy, and none of that has transformed for 20 years. Let me tell you what we just did at Dartmouth. At Dartmouth, they have finally eliminated all of that on-prem stuff. Their cloud, their whole NAC system is now running in the Mist cloud, and it seamlessly speaks to eduroam, and they can manage the whole thing on the cloud, right? So we have launched the first cloud-enabled NAC for eduroam deployed in production now. And so, yes, you can troubleshoot it, especially because what you want to know is, as a remote user, is it even hitting my home org, right? You could see that in the cloud. You don't need, obviously your IT team can see that in the cloud and easily. We have a virtual network assistant. It's available on Teams. Marvis is our virtual network assistant. It actually is available on Teams. You can literally ask Marvis, hey, what does my authentication look like on eduroam? And am I connecting to my home org or not, whatever? You could self-serve. Like ServiceNow is one of our customers. They're building this virtual network assistant built into their organization as well. So eduroam needs to be transformed. And I think we just landed the first university, others to follow, because we just released this feature. Dartmouth is running in production.
Okay, thanks.
Awesome. Thank you.
Okay, so now we're done.
Now we're done. But we're outside. Thank you very much.